Hello class, this is my Project 2 final. My Project 2 final is on a quality control circuit board inspection. It's pretty much a voltage measure where you can actually measure different voltages, DC voltages using our Arduino. My agenda, I'll go over the schematic, the parts list, the PCB layout, the actual PCB itself, the Arduino connection to the PCB, and my references, and then a demo on my unit. Here's my schematic. Over here is the actual voltage divider circuit that will be measuring the voltages from each voltage regulator on the different PCB boards. Over here is my addition circuit that I had to put in before I was running the Arduino, powering it with 5 volt off the USB. But to put it in an actual housing, I had to put in an actual 9 volt linear voltage regulator so I can actually run the Arduino. Also have 24 volts going into the system. And that, in parallel with that, I have 24 volts that will be powering the actual circuits that we'll be measuring. I have an LED with the switch over here. I have 2 capacitors per the spec of the linear voltage regulator to clear out any voltage spikes going in or coming out. Over here is my LCD hookup. That's taking 5 volts from the actual Arduino and using a couple of potentiometers, variable resistors, to control the LCD. One of my learnings from this circuit was when I put this thing together, my LCD didn't go on. It was just completely black. I thought it might have been something to do with the actual potentiometer there, that it wasn't working or wasn't hooked up right. So I replaced that and it wasn't that. I ended up finding that my line 16 up here was just floating. I never hooked up line 16 to ground. So what I had to do was jumper that just using the jumper wire. Here's my parts list for all my components to make this. I'm not going to read each one off to you, but it's pretty much resistors, diodes, capacitors, linear voltage regulator, some cables, header connectors. Here's my PCB layout. So when I wanted to put it in a box, I wanted to actually do a PCB. We do PCBs here all the time, so it'd be a good learning for me to do it. So this is my PCB layout. I made it to match exactly the Arduino. Here's all my voltage divider circuits going on right here. All this area here is my power to run the Arduino and the incoming power. Over here is my LCD to control my LCD. I have the 2 pots here, and I actually did the pin out the same way as the Arduino so I can go right over it. And here's my LED header connector here that's connected to all those. One thing about doing your PCB board, you have to understand and learn the manufacturer's packages, sizes. In this setup, I use the 1206 package. That's the actual footprint. There's 603s, 1206s, a bunch of different package sizes, and it's actually the size of the component. So I use 1206s, like I said. I couldn't use a 603 as I originally wanted because I needed a 2-watt resistors, and they didn't have 603s in a 2-watt resistor, so I had to go up the size of the package. Some of the learnings on this. The footprint on my voltage regulator was too big, but it didn't matter because it still worked and it just acted at heatsink. Here's my actual PCB board. One of the requirements for this project was to solder components. Here are all my components soldered on. You can see that the footprint here was too big on the voltage regulator. One of my learnings from this part here was this header connector actually was touching the Arduino when you stack them over each other, so I had to put an insulator in between the two so they wouldn't ground out or short out. Here's my board stack. So here's my actual design up here, and you can see that it sits really nicely right on top of the Arduino, and every pin goes right into its right location. Here are my references. And here's my circuit demo. So I'm going to bring it over here. So here's my actual box that I designed. You have a switch here. When you turn it on, the red LED will go on to let you know that it's on. You have the LCD. You have that 24-volt input here. And then you have these jumpers where one is going to measure the voltages and then the other one is going to measure the power it's actually going to power the circuit boards. So we have a 24-volt input here. We'll turn it on and you can see that the red LED goes on. And it should be measuring 0 voltages because there's nothing hooked up. So voltage regulator 1, 2, and 3 all say 0. We'll turn it off and we'll put on an actual PCB board circuit that we make here that we want to test. And the reason for making this was to be really efficient and quick on measuring the different circuit boards. So we'll turn it back on. And you see that all three green LEDs go on. That's telling you that all the voltage regulators are working. And voltage regulator 1 has 5 volts, 2 has 12 volts, and 3 has 15 volts. So this circuit board is good, so they can use this and put it in one of their systems. So we'll turn it off and we can measure another one that I know is bad. We'll swap it out here. We'll turn on this one, and the 2 LEDs up here are obviously off, telling you that the 2 voltage regulators are bad. And you can see where voltage regulator 1 is 0, voltage regulator 2 is also 0, and voltage regulator 3 is 16 volts. So only 1 voltage regulator is working on this whole board here. And the reason we have to measure all these is because we don't have a solder flow oven, so it's really hard to solder these voltage regulators onto these boards. So a lot of times they end up shorting out. So you can see that the solder here is really thick and will end up shorting out. But so this is going to be handy for us. We can use it actually here in-house and use it to test all our boards. Thank you guys very much. That's all I got.